In this video, I'm going to show you how you can prove that a matrix is orthogonal, and I'm going to define what an orthogonal matrix actually is. So let's start with a key idea, the fundamental principle involved, and that is that a matrix is orthogonal if we can say that the following statement is true. So if you can prove that the transpose of the matrix is equal to the inverse of the matrix, then you will have demonstrated that the matrix is orthogonal. This isn't the simplest way to prove it, and what we can do is apply a simple trick and come up with a slightly nicer expression to also show that it's orthogonal. So let's multiply both sides by q, and we get this expression here. And you'll notice on the right-hand side that we have q times q inverse. So we've got a matrix times its inverse. That's going to give the identity matrix I. So we've now got this nice simple expression here. So we don't even have to find the inverse. All we have to do is do a simple matrix multiplication between q and its transpose. Finding transposes is easy, and matrix multiplication isn't terribly difficult. So we have a nice expression that will allow us to prove that the matrix is orthogonal. So let's look at a worked example. So we're going to prove that this matrix here is an orthogonal matrix. So the first step would be to find the transpose. So that means that the rows of the matrix become the columns. So here is what the transpose will look like. So this row has become the column here, and this row has become a column here. Very straightforward. In the previous slide, we've seen that q times q transpose is equal to the inverse. So let's just multiply those two matrices together. And we'll do a matrix multiplication. So we need to find what the multiplication of these two matrices are. So we need to do this row multiplied by this column. So we'll do it element by element. So it'll be this multiplied by this. You'll notice you've got a minus here and a minus here. So you've got two minuses. So it'll be this times this. You'll notice it's the same thing multiplied together. So you're going to get a squared there. And this is going to be when that's those two are multiplied together, that'll give you a squared. And so you're going to get this expression. Then you need to do the next multiplication. So this row into this column, giving you this expression here, which you'll be able to simplify in a second. And then you do the two remaining multiplications, so just simple matrix multiplication to give you all of this. And if you were to simplify all of that, or perhaps MATLAB or a computer program to do the multiplication for you, you'll end up simplifying all of this down, and you will see that, for example, these two will give you 1, and these cancel out, giving you 0. And so you now have the identity matrix. So we have the situation where matrix Q multiplied by Q transpose is giving you the identity matrix, and therefore Q is an orthogonal matrix, and you have proven that the matrix is orthogonal. So that is how you prove a matrix is, in fact, an orthogonal matrix, and all of the properties of orthogonal matrices come to that particular matrix. So you know quite a lot about that matrix now. So hopefully this video was helpful to you. If it was, please subscribe below. And finally, thank you very much for watching.